Alright folks, so this probably is not the most effective, but what we're going to do is we are going to go through Chapter 16, Spontaneity, Entropy, and Free Energy. I'm going to upload the notes to the AP class website, and I would like you to, if you get a chance, go and download those. And we're going to watch our videos at home. I'm going to upload a video for Friday and for next week. You're going to watch those at home for homework, and then we will come to class and we're going to do some practice there. Alright, so what is spontaneous? That's when a reaction is going to occur without outside intervention. We cannot determine how fast or the rate of the reaction, but we need both thermodynamics and kinetics to describe it completely. So thermodynamics compares the initial and final states, state function. Kinetics is going to describe the pathway of how I get from A to B. Or maybe I go from A to C to B. Alright, first law of thermodynamics. The energy of the universe is constant. We do not create or destroy matter. Likewise, we are not creating or destroying energy. We're shifting it about. Alright, so we keep track of thermodynamics. It doesn't completely or correctly predict spontaneity, but we get a really good idea. Alright, entropy is disorder or randomness. Second law, the entropy of the universe increases. So energy has a tendency to go from a organized to more organized to a less organized state. Normally in chemistry we're going to think of heat as being the least organized. Entropy can be defined in terms of probability. Substances that take arrangement that is most likely. So an example here is, the most likely is often the most random. So we calculate a number of arrangements for a system. So when we start talking about entropy, we start looking at the actual probability of, is this going to happen, and if so, what is the likelihood? So here we have our standard example. What's the likelihood that our yellow dot will be on the right side? And what's the likelihood that the yellow dot will be on the left side? Of course, it's 50-50. So there are two possible arrangements. Now, what's the likelihood of them being evenly dispersed? Well, I have a 50% chance that they are unevenly dispersed, and therefore a 50% chance that they are evenly dispersed. Here we have four possible arrangements. Right? 8% chance of finding the left empty, 50% chance of finding them being evenly dispersed. Right, this is going to take us to gases. Gases completely fill their chamber because there are more ways to do that than to leave it half empty. So we have motion of gases, and now we're starting to talk about placement. So the entropy of a solid is less than that of a liquid, which is much, much less than that of a gas. Right, this is a really important point. You need to make sure that you're really focusing, because this is where we're talking about being a state function. Right, our solids are organized, liquids are relatively organized, gases are very disorganized. Right, there are many more ways for the molecules to be arranged as a liquid, many more ways for them to be arranged as a liquid than a solid. And then gases have a huge number of possibilities. Right, solutions form because there are many more possible arrangements of dissolved pieces than if they were to stay separate. So delta S of the universe equals delta S of the system plus delta S of the surroundings. Delta S of the universe is positive, the process is spontaneous. If delta S of the universe is negative, the process is spontaneous in the opposite direction, or the reverse reaction. Alright, we're going to have to go to another video.